Hello, everyone. Welcome to the second session of our invited talks. This session is organized around the themes of privacy, safety, evaluation, and explainability, and we have three great speakers with us today. I'm Gina Laveau, and I'm from the University of Washington. I work mostly on spoken language understanding and spoken dialogue systems. I'm very happy to be able to introduce our first speaker this morning. Our speaker is Professor Irina Rish. Professor Rish is an associate professor in the Computer Science and Operations Research Department at the Université de Montréal and a core faculty member of MILA, Quebec AI Institute, and where she holds two prestigious chairs. She received her Master's of Science and PhD from UC Irvine. And prior to joining Université de Montréal, she was a research scientist at the IBM T.J. Watson Research Center, where she received multiple IBM awards. She's the holder of many patents, and her research focus is on machine learning, neural data analysis, neuroscience-inspired AI, and this spans a broad range of projects. Today, she'll be talking to us about dialogue modeling via hash functions, applications to psychotherapy. Please welcome Dr. Rish.
Well, thank you so much for a great introduction, and thank you for inviting me to this event. I'm actually really happy to talk about this work at the intersection of machine learning and applications to like neuroscience and psychiatry. That's specifically a topic of my talk today. While the session is more on privacy and safety and related topics, the medical applications in psychiatry definitely have some elements of that. That's why kind of my talk today is going to be more about the general approaches to dialogue modeling with specifics that you encounter in this type of applications. So let me share my screen and start the presentation. Okay. So this is a joint work in collaboration with multiple people, and primarily was led by our intern at IBM, who graduated also recently from University of Southern California, Sahil Garg. So this work was kind of the result of 2 years of effort on his side, and collaboration also with my colleague Guillermo Chechi from IBM T.J. Watson, who leads computational psychiatry and neuroimaging group there, as well as our USC collaborators listed here. So just to give a quick perspective about this whole new emerging exciting field at the intersection of language, psychiatry, and artificial intelligence, there are many potentially interesting signals about the mental states that can be learned, discovered in language, in interviews, in even written language. And while I'm not going to give you the full overview of what the computational psychiatry group at IBM, which I was part of up until last October and still continue collaborating with, there is a lot of examples of the type of work at this intersection where signals about different potential mental disorders or just different mental states can be elicited from text or speech. And indeed, I can only 100% agree with this classical saying by commenting that language is a window into the brain. So why application of AI to psychotherapy? Well, there are multiple reasons why we think this area is particularly hot right now, and indeed is very practical, and there is a lot of need for more automated computational methods in this field. So first of all, according to estimates and predictions by the World Health Organization, mental disorders such as depression are on the rise. I mean, I don't think I need to convince anyone because we all know that, and especially in the last year with pandemics, the mental health issue becoming more and more acute. So it's not just kind of threat of virus, but it's also threat of deteriorating mental conditions. And some of the predictions are pretty scary about depression becoming one of the like really serious sources of disease and accident and basically even death in the future decade, even kind of becoming as serious or maybe more serious than some other classical diseases. The problem is also that even with the best therapists out there, the number of people who would need the therapy and could benefit from that is orders of magnitude more than the number of the specialists. And even if you manage to get an appointment with a good one, you're probably not going to see that person more frequently than once in 2 weeks or once in a week. Bottom line is that there is so much demand for psychiatric and therapeutic services, and there is not enough supply. And this gap is only widening. That triggered us and many others to think about various ways of automating or at least partially automating functions of a therapist. And any progress in this direction could be very useful. Although, of course, I mean, no time soon we are planning to replace human therapists. What we're talking about here is potentially automated tools to help doctors to kind of fill in between the visits, to be able to maintain perhaps some simple dialogue with patients and alert doctors or family if certain kind of dangerous changes in their behavior might be detected. So ideally, you would like to have a chatbot, like in the movie Her, which can be with you 24/7, listening to you, talking to you, and detecting whether your mood and mental state changes and whether those changes require additional attention. Anyway, so this is more like a futuristic outlook, but what's going on right now? There are various data sets, and luckily some of them are even publicly available. For example, the Alexander Street data set that we used in this study, it's relatively small as compared to much larger scale data sets such as Twitter data, or of course, recently used data sets for training models such as GPT-3. So what we were doing was not anywhere close to that scale, but actually the point was that with available therapy data out there, what can we do and what kind of models can handle such relatively small ones. By small, we mean that, for example, we have roughly 400 therapy sessions and maybe a few hundreds of patients, and maybe you have something like roughly 40,000 dialogue pairs or samples. No state-of-art deep learning system would be really able to learn a seriously good model out of this tiny by modern standards data. And indeed, in our experiments, that's what we observed. But potentially alternative approaches based on different principles might be able to utilize such relatively small data sets. And that was kind of one of the points of this work. So if you look at those dialogues, they have kind of specific structure. So it's not like arbitrary open dialogue, but rather patient comes to therapist and talks about how they feel and what they think. And it's typically a bit of a longer paragraph, sometimes a few paragraphs, while the therapist replies in a relatively short, concise form. And as you can notice, it's kind of reply that tries to be aligned with the meaning of what the patient was saying. For example, in this first example, patient talks about what's going on and says that you begin to generate feeling of kind of negativism, and that's why it really being heard. And the therapist replies briefly, but trying to align that answer with the main theme of the patient's kind of statements. Yeah, it fits in the whole pattern then. So on and so forth. So it's a bit hand wavy, but trying to kind of characterize what's special about this type of dialogue. Patient responses can be very long, but the response of the therapist that you would like to generate is usually shorter, higher level. It's like a label summarizing what the patient is saying and kind of paraphrasing to some extent. Also, especially in the beginning of therapeutic sessions and in the beginning of the interactions between a doctor and a new patient, it's well known that the main goal of such dialogues is to achieve alliance between patient and therapist. And that also triggered our thinking about what could alliance mean and how would you formalize it? What does it mean that response is good? Anyway, there are actually other examples besides therapy of this type of dialogues, and this is just yet another data set that we played with as well. For example, it's interviews by Larry King of various guests in the studio, and they have similar pattern. The guest usually talks about some events or thoughts, and the role of the host in the show, like Larry King, is to provide some alignment, summarize, provide kind of label to what the person is saying, and also direct the dialogue in a certain kind of desirable direction. To make long story short, without going into too much detail, I just want to say that as an alternative to classical deep learning approaches to learning text representation and generating dialogue, and there is lots of state of art in this area, of course, we thought about an approach that is rather based, in this case, on hash codes. So essentially, think about that. If you manage to map your sentences into points and some space, and then basically encode the meaning of those by, say, few hundred bits vectors, where each bit can be generated simply by randomly splitting the points into two parts and learning a classifier to label the point based on this like random. So basically you kind of generate a split of the data, train a classifier, and that classifier will encode for that split. So whenever a new point comes in, you know how to generate that bit. Then another split of the data will be responsible for second bit, so on and so forth. And you have perhaps hundreds of such kind of randomly created classifiers, randomly created data sets, and classifiers trained on them. So bottom line, you will be trying to encode the meaning of the text by combination of multiple such binary patterns, which can hopefully represent certain elementary atomic patterns of the meaning. Again, this is at very high level. For details, you can see the paper, but the idea here will be once you're able to encode what the patient is saying and what the therapist is replying into these binary hash codes, in that representation space, you would like those two to be aligned, and you can use mutual information as one reasonable metric of alignment, which is also very useful to optimize if you want the response to be as predictable as possible given what the patient is saying. So if you learn your representation mapping, learn your embedding function based on maximizing mutual information between the two participants of the dialogue, then essentially it will be easier to predict what to say in response to a new patient's, roughly speaking. So there is, of course, tons of related work on this topic, and there are different flavors of our approach here and there, but bottom line is none of those was really capturing everything that we wanted to capture. So there are many, many chatbots, including therapeutic ones, and especially more recently. And one classical example is this boy bot from Stanford. And many others. But unfortunately, most of the time, such approaches are based on pre-programmed responses that the user is supposed to choose from. So it's not really a dialogue where the system tries to model the meaning of your open kind of response and try to generate its own response. It's pre-selected, pre-programmed set of answers typically. There are many neural net approaches here, but they usually do not handle that well when you have such imbalanced kind of dialogue with extremely long patient responses. Also, it might not be always that obvious how to implement the notion of alliance or information theoretic measures and so on. So on and so forth. Task-driven dialogue assumes that there is some notion of what is good or what is bad dialogue, whether you completed task or kind of you're performing well. But it's hard sometimes to measure that in dialogue such as therapy, because the results might not be seen anytime soon. Anyway, just to make the long story short, in this approach, we proposed this framework based on hash code functions, very different approach to learning representations than standard fitting of kind of neural network compound functions or deep nets. We used heavily the notion of mutual information as a measure of alliance and the guide to learning, to building those representations. And because of that, not only we try to achieve better alliance between, say, patient and therapist or the host of the show and the guest, but also we were making the responses more predictable and easier for us to generate. From theoretical perspective, I'm not going to go into detail, but we had to derive some lower bound, basically tighter upper bound on joint entropy and the bound on the mutual information lower bound, because just computing it on high dimensional data is intractable. So you need to kind of be smarter about that. But essentially, bottom line is, with this approach, we were able to handle relatively small data sets, like the ones I showed you, and do a pretty good job generating reasonably meaningful responses, while our competitors, such as a few deep learning systems, as expected, were not able to utilize this relatively small data set because they really required much larger data sets to be trained well. Okay, so without, again, going into too much detail, I just want to give you the gist of the approach. So once you encode your patient and therapist or any other two participants of dialogue sentences into these binary hash codes, you can view first one as essentially a feature vector, while the second one as a label. And in the test regime, when you see a patient saying something, you map that paragraph or view as a whole into the feature function, to the representation, and predict what the hash code should be for the response. And then, as a separate procedure, you will have to map hash codes back to text. So in a sense, you have this three components of the approach. There are multiple different ways to actually learn those hash functions, and they vary by which classifier you may choose in order to create your bits. So say you can use nearest neighbor, and then you need to decide what's going to be your reference set, how you're going to split your data points into positive and negative. But once you do, any new data point or the text from, say, patient can be easily mapped into the corresponding bit using the classifier. And then you do multiple such splits of the data and therefore train multiple classifiers. Classifiers could be not necessarily nearest neighbors. They can be, of course, SVMs, and then you just do this random lines over your data sets, or it could be anything else. But just keep in mind that anytime you have a classifier, to train and a reference data set, you have various hyperparameters, and training those can be guided by some criterion, which in our case was this mutual information. So of course you can do, and we tried that as well, the neural hashing when your classifiers are encoded by deep networks, and the architecture of those is also a set of parameters that need to be optimized with a particular criterion, which again in our case was mutual information. So eventually, the overall picture is indeed you take the mutual information between the hash code of a therapist and hash code of the patient, use it as optimization criterion when learning those representations. And once you do that, at the test time, you just use encoding of the text into those binary vectors and perform prediction of the response given utterance of the first person. I don't have much time to go into detail of the mutual information lower bound, but it involves the notion of total correlation or multivariate mutual information, and details for derivation are in the paper. Results. So the interesting thing here was that we used human evaluation to compare multiple models and to see how well they perform from the point of view of actual people. We also used multiple metrics that are typically used in dialogue, but those, as it's been pointed out multiple times, are not always reflecting the best the quality of dialogue generated. So in this case, we compared three systems based on deep learning. The last one, BH-RAD, was from Julian Serban's paper a few years ago, who was also at Mila. And at that point, it was indeed state-of-art system, so it still remains kind of pretty high-quality dialogue generation system. And there were some more simplistic approaches, some previous LSTM and HRAD. Bottom line is we tried three flavors of the hash code-based approaches with variants in which classifier we used. They're basically k-nearest neighbor, max margin, or SVM, or LSTM embedded in this hash code approach, where LSTM was actually used for encoding as a classifier for creating those bits. Bottom line, so what do we see here? We had about like 108 people participating in this study, Amazon workers, and they were rating the responses given by each of those 6 systems. And as you can see, in terms of diversity of responses, not repeating the same kind of simple thing all the time, and just giving really different responses to different questions and different kind of utterances. Also, appropriateness of responses. Our 3 models were by large margin considered much more kind of meaningful than the competitors. So essentially, they took like more than 80% of the votes. And just to give you some examples of what was actually happening here, for example, the short dialogue between patient and therapist, where patient was kind of happy that he or she lost several pounds and asking whether therapist noticed that. The real therapist replies, "That's great, I did notice that." The hashing methods give replies to different degree of kind of with different quality, but still they're somewhat meaningful. Yes, you did. Well, to help you with your diet, or what's the explanation, which may be a little bit off. Still, all of that was considerably better than looking at the responses provided by, for example, just the LSTM. In this case, I mean, the poor system just was not able to learn anything meaningful from this apparently too small of a data set, and was just generating some repetitive response. The 2 other more recent systems were generated pretty much the same response, like, yeah, you, not too meaningful, and absolutely not diverse, unfortunately. Well, bottom line, it was quite clear that those systems may require much larger data sets, and apparently they did. So they just couldn't handle this small data set. Another example was actually just a bit funny, and that's part of the reason I included it here, when a patient was complaining in general about difficulty of getting therapist and so on and so forth. And our system was replying to different extent meaningfully. It was just unintended sarcasm when our system just was asking patient, well, yes, if you have such a difficulty getting therapists, did you try medications? Anyway, sarcasm was not intended, but I just wanted to show it for fun. Bottom line, the point of the slide is that unfortunately, the competing systems, again, were not able to learn anything useful. Their responses didn't make that much sense. They were very repetitive to pretty much whatever the patient was saying, just like the Amazon Turkers evaluation that I showed before. And finally, we also were kind of curious to see that, okay, with this information theoretic measure between, or of alliance between what patients say and how therapists reply, we also might be able to use it to get some idea about how the alliance is building up during the session. And that could give us some ideas, maybe how evaluate whether sessions are overall good or bad. Again, it's very imprecise and initial attempt to characterize the quality of particular sessions. But with metrics like that, or perhaps better metrics, there are many things you can do. You can basically provide evaluation of session to therapists who are just in the beginning of their career. You can pretty much kind of use those systems to maybe train them better. So basically you can provide these different metrics of how well they did during the session. So it's not just generating responses for actual patient or user, but it's also training therapists to do a better job. And I think I'm running out of time. So I just want to say that there are, of course, multiple directions for future work here. And definitely, I mean, we could combine this with pre-training on much larger and perhaps well, unlabeled data sets, which are not necessarily at all dialogue data, basically just to learn better representations. And that, I'm pretty sure, going to improve quality of the model. And again, it may allow us to use maybe this large-scale state-of-art neural net models, which will hopefully shine once the amounts of data will be considerably larger than what we typically have in medical applications. But the point here is when the data are limited, and medical applications are a good example of that, you do need some approaches that may be able to still make sense out of this data before you collect much larger scale data sets. Before that happens, and you can apply, I don't know, GPT-3 size of transformers to that. Definitely, it would be interesting to look at the interpretation of the patterns learned by those hash codes, because we hope that they may kind of be analyzed and interpreted as some basic units, basic atomic components of that, what makes that, I don't know, called dialogue, what kind of basis components are there in terms of meaning. Basically, just to play the reverse engineering and interpretation kind of a game here. And definitely, there are many other things in terms of like semi-supervision. We could also provide some notion of what we think was a good dialogue versus bad dialogue if we show those to the experts in the field. We didn't have access to them at this point, but in the future, we could do that. So there are many potential extensions of this type of work, and even an idea of giving those small data sets perhaps as a prompt to highly large-scale models such as GPT-3 is another potential idea for future work. So it will be one 40,000 sample kind of a prompt, but perhaps it may really provide lots of information about this type of dialogue in psychotherapy, to a huge pre-trained natural language model. And that's kind of the vision of the future, where hopefully our needs that are not quite met yet now can be partially met, at least with virtual therapists or virtual therapist assistants. Thank you. I'm done.
Great. Thank you very much. So we have time for, I guess, a short question or two before moving on to the next speaker. So we had a question from Will Kearns, and he was asking to what degree he thinks it makes sense to model human-machine therapy on human-human therapy. For example, the types of dialogue data in the Alexander Street data.
So let me see if I understand the question. To what extent does it make sense to model human-machine dialogue based on human-human dialogue?
Well, in the case, I think in the context here, the question is, the therapist is probably going to understand what's going on and what the patient says better than the system. And given that the system may be limited in its understanding and its understanding of the larger context, for example, of the therapeutic setting, it might be awkward to, for example, back channel a lot or use or provide an inappropriate response relying on synthesis.
Yeah, I agree that this is always a danger with applying dialogue systems, especially in medicine, as we know from a very recent article, well, again, about GPT-3, which suggested to an imaginary patient to kill himself. So yeah, you will have to be careful about perhaps checking responses before kind of giving them a real chat to a patient. But what I was trying to say here, that actually if you look at majority of responses of therapists, when they just maintaining this type of dialogues, they essentially like summarizing, aligning themselves and kind of confirming what patient is saying. And most of the time, in many studies, it was shown that sometimes people really just need to talk to someone and hear affirmation. So it's not really that the system is asked here to give some sophisticated advice or anything. It's just being asked to maintain the conversation and support kind of the line of thinking. So when this function is like relatively simplified, that at least I think part of those functions can be performed by the chatbot. But of course, it shouldn't be chatbot on its own. It should be evaluation of and kind of constant evaluation of you if you think that person is kind of too disturbed or so on. So maybe if the deviation from normal starts being a little bit too large, you need to know, the system needs to know when to connect to the human. Yeah. So it should be kind of intermediary, but it should not by any means replace the therapist. It should kind of fill in the gaps which are easy to fill in and know when to alert the person.
Perfect. Thank you.
Yes. I would say.
Yeah, that's a great response and great insights. So I want to point out that there are actually a bunch of other really interesting questions in the chat. So if you have the time to go over there and try to reply to them in the stage chat, that would be fantastic. But we should probably move on to the next speaker. Thank you again for a really exciting talk.